Why do all planets just float in the universe? Earth weighs 60 septillion tons. Why doesn't it just plunge? Every night, when we look up at the stars, those twinkling lights hide countless planets just like ours. They are quietly floating in the vast cosmos, just like Earth. So, what force is strong enough to keep countless planets steadily suspended in space? Today, we are diving deep into this cosmic secret to see how the universe keeps everything in its perfect place. To solve this, we need to understand the universe's most sticky force, universal gravity. We all learned the term gravity, but its magic is way beyond what you imagine. Over 300 years ago, Newton discovered this basic cosmic law. Every object with mass has an attractive force to every other object. The bigger the mass, and the closer the distance, the stronger the attraction. You even have gravity with the person next to you, but your mass is so tiny, we can't feel it. But swap in giants like Earth and the Sun, and gravity becomes the invisible rope controlling all cosmic order. In our solar system, the Sun is the biggest object. Its mass is 99.86% of the entire system. That's like 330,000 Earths combined. Its gravity acts like a giant, invisible hand, firmly gripping every object in the solar system. That includes the 8 planets, moons, asteroids, and comets, all pulled by this force. Earth is no exception. Solar gravity is constantly pulling Earth toward the Sun, like a parent holding a running child. But here's the cool part. Earth hasn't been pulled in. Instead, it has been circling the Sun for 4.6 billion years. Why? That brings us to the other key player, centrifugal force. As Earth orbits the Sun at 29.78 kilometers per second, it generates a massive centrifugal force. This force perfectly balances the Sun's gravity, which is why Earth stays stable in its fixed orbit. It won't crash into the Sun, and it won't fly out of the solar system. Here's the fun part. Why hasn't Earth fallen? The truth is, there is no up or down in space. On Earth, an apple falls, and you land after a jump. That's just Earth-specific gravity. But in space, with no fixed reference point, all directions are equal. All planets are suspended in space. They don't fall toward any direction. So, floating is just what we perceive. In reality, they're moving at high speed in their orbits. There's just no familiar ground for them to crash into. And another crucial reason, the vacuum of space. On Earth, whether you run or throw something, air resistance is always slowing you down. A thrown ball eventually stops, and when you run, you feel the wind pushing you back. But space is the closest thing to a perfect vacuum we know. There are almost zero air molecules. Planets move with virtually zero resistance. Even more amazing, the entire solar system is blazing through interstellar space, following the Sun. The Sun is dragging all its members around the galactic center at an insane speed of 220 kilometers per second. That speed is completely impossible to imagine. But all objects are moving in sync. It's like sitting on a bullet train where you and your neighbor are relatively still. We don't feel this super high-speed motion at all. The Sun is held by the supermassive black hole at the galactic center, creating nested, orbital systems, just like Earth and the Sun. The entire universe acts like a precise clock, with every part moving by the rules. Besides orbiting the Sun, our Earth is also spinning on its own axis. Earth's rotation speed is 465 meters per second, about half the speed of a commercial jet. It's this rotation that gives us the daily cycle of night and day. Interestingly, the centrifugal force from this spin makes the equatorial radius 21 kilometers longer than the polar radius. It's like it's been spun into a slightly bulging ellipsoid. While this centrifugal force doesn't do much against solar gravity, it's vital for Earth's own stability. It helps maintain Earth's magnetic field, regulates climate, and more. Some people worry, will this balance suddenly break one day? What if Earth slows down its spin, or gets hit by another celestial body? Actually, the universe is far more stable than we can imagine. Our solar system is 4.6 billion years old. The orbits of the 8 planets change very slowly. Earth's orbital period error is only a few seconds per million years. To break this balance, we'd need an interstellar event, like a massive rogue star breaking into the solar system. Its gravity would mess up the orbits, or a supernova shockwave would sweep through, changing our motion. But the chances of this are extremely low. Scientists calculated that no massive star will enter our solar system's vicinity for at least 1.29 million years. One possible change won't happen for 5 billion years, when the Sun turns into a red giant. The Sun will expand, swallowing Mercury, Venus, and possibly reaching the Earth's orbit. Even then, the change in solar gravity will be slow. Earth won't suddenly lose control and plunge. Plus, at the pace of civilization, 5 billion years from now, humans will likely have found a fix. We might even move the entire Earth. In a way, Earth is always falling, it's just falling toward the Sun. Because the Sun is flying forward, and Earth is chasing it. A 4.6 billion year chase never missed a beat. Ancient humans had no instruments, only naked eye observation, yet they mapped the movement of the stars. They created calendars and guided agriculture. It wasn't until Newton and universal gravity that humanity truly began to unlock the cosmos. Now we know those twinkling stars are all celestial bodies, orbiting their own stars. Because of external gravity, Earth is stably suspended in space, orbiting the Sun. This stability is exactly what gave Earth its life-sustaining environment. The surface temperature is moderate, the rotation period is just right, keeping day-night temp swings non-extreme. And another factor, Earth's distance from the Sun is just right, not too far to freeze, not too close to fry. These seemingly accidental conditions are the result of long-term cosmic evolution, and humanity is the lucky recipient. When we see the Moon orbit Earth, and Earth orbit the Sun, don't you feel how marvelous the universe is? It didn't let massive planets randomly smash into each other. It wove a safety net with gravity and motion, allowing life to thrive and survive on this planet. This beautiful blue planet holds mountains, oceans, and life, carrying the entire history of human civilization. It's not lost and alone like a rogue planet. It orbits stably in the solar system, steadily carrying the miracle of life. Now we launch probes to explore the solar system and even observe galaxies billions of light years away. But the more we explore, the more we feel the vastness of space and the preciousness of Earth. In the known universe, no second planet with intelligent life like Earth has been found. Those seemingly floating planets are actually guarding cosmic order in their orbits. Earth is the most special one, because it is humanity's only home in the universe. And a home like this is unique. It's worth protecting for a lifetime.